Hello everyone, welcome back to my YouTube channel. And today we will be discussing consistent hashing. So, guys, before starting consistent hashing, let's understand what problem we are solving with this and what are the issues and why do we need to know what consistent hashing is. Okay, so in the previous video, I have talked lots about sharding, data sharding in saving data in different nodes. Okay, so let's go deeper inside that. Let's suppose there are three shards where you are saving data of a user, okay, and we have sharded based upon user ID. So what would be happening in the background is you will provide a user ID, and based on the user ID, there will be some hash function which will decide which shard to fetch data from, or which shard to save this data in. Okay, so let's suppose you have provided some user ID, it is saved in shard one. So now you will expect, like, whenever I give a get query with same user ID, uh, my query should go to shard 1 and fetch data, because in shard 2 and 3 you won't get that data. Okay, so this behavior we want, but how we will achieve with hashing, what this hash function should do to achieve this functionality. So let's suppose we are using a simple mod hash function. Okay, so we have three shards here, so we have done mod 3. So if user ID is 1, so you will you will use mod 3, so you will be redirected to shard 1 for 2, for shard 2, for 3 shard 3, because here the remainder will be 0. So for 0 I'm referring to shard 3. Okay, similarly, if the next user ID comes as 6, it will again go to 3, 9 again 3, 12 again 3, and 15 again 3. So there is one problem which we can see here is, first of all, if this is a pattern of user IDs, one shard has more data than another. Okay, if you see that shard 3 has your details of 5 user IDs, but shard 1 and 2 has details of only one user ID. Okay, so this is something which we don't want. Do you always want that our data should be equally divided if we are maintaining shards? This is the first problem. What is the second problem? Let's suppose now you want to increase a shard. There were three shards, now you want to make it four. And again, you are using the same mod function. Okay. So now since you have four shards, so obviously you will be going to change your mod function by doing modulo 4. And let's suppose your keys are this. User ID 1 comes, it will go to 1, 2 will go to 2 again, 3 will go to 3, but 6 will not go to 3. This time it will go to 2, 9 will go to 1, 12 will go to 4, and 15 will go to 3. So since we saw earlier the shards where these user IDs 3, 6, 9, 12, 15 all were going to 3, but here it is not the same. So again, the second problem is, if we increase shard at any point of time, the rebalancing happens, and this rebalancing is happening between all the shards. It is not limited to one or two shards. All shards are getting rebalanced. So now, let's suppose user ID 6 was saved in this shard 3 earlier. As we increase shard 4, when get request comes, it will go to shard 4. It will it will go to user ID 6 will go to shard 2, not to 3. But in 2 it will not get that data, and it will return that data not found, which is incorrect, because data is there in shard 3. So now you will say that we can do data replication, but in how many shards will replicate data? If you are replicating all the data in every shard, then what's the point of sharding here? Okay, so that is similar to master slave architecture, not sharding. So if we are doing sharding, we cannot replicate every data and every shard, because there is no point. We are not solving anything. So to solve this problem, consistent hashing came. And let's see how we can solve this problem using consistent hashing. So in consistent hashing, what we do is we let's suppose there is a virtual ring, there's some ring, okay, and for example, I've given it from 0 to 11, okay, it can be from 0 to n, any number it can be, okay. So for simplicity, I've given till 11, okay. Now what I'll do is I have three shards, shard 1, 2, and 3. So I will place these shard at three random points. Okay, so shard 1 is point 0.2, shard 2 is point 0.7, shard 3 is point 0.10. Okay, so now how consistent hashing works is if your mod function or any hashing functions, we have made this ring in a form that a hashing function will return us results from 0 to 11 only. So if we pass any user ID to a hash function, it will return us results in range of 0 to 11. Okay, so this is what it will do. How can we now see that our problem is solved is, let's suppose our value from hash function comes 2. It will obviously go to shard 1. Okay. If it comes 7, it will go to shard 2. If it comes 10, it will go to shard 3. But what if it comes, the hash value comes 1? What will do? As soon as hash value comes 1, it will go to shard 1. Now you'll say why. So what we have done here is we are maintaining a clockwise direction. Like if anything is coming at this point, it will go to its next, the shard at that point. If there is no shard at that point, it will go to the next shard at next point and see which shard is there. So it will always see in clockwise direction. So after 1, it's 2, so it will go in shard 1. Similarly, if some values comes at 11, although 10 is closer, but again, we are maintaining this clockwise direction pattern. So it will go to shard 1 again. So if a mod value is 0, it will go to 1, 1 to 1, 2 to 1. So see, if 0, 1, and 2, everything is going to shard 1. Now 3, 4, 5, 6, 7 is going to 2. 3, 4, 5, 6, 7 is going to 2 here in clockwise direction, and 8, 9, 10 will go to 3, and again 11, 11's next is 2, so it will again go to shard 1 since it is a circular ring. Okay, now this is our consistent hashing, but let's see how it is solving our problem. So first problem which we faced was, let's suppose a new shard comes. Now we'll see, let's suppose shard 4 comes at this point. So what will happen? So if you see carefully, there's nothing happening between points lying between 7 and 10. It will happen nothing to that point. So anything coming at 8, 9, and 10 will go to 3. Anything coming at 11, 0, 1, 2 will go to 1. Okay, now anything coming to anything coming to 5 and 6 will go to shard 2. This was happening as earlier, okay, but there's one catch here, that anything coming to 3 and 4, it was going to shard 2 earlier, but now it will come to 4. This is the difference, only difference. Okay, so if we see that the rebalancing has only happened for one shard here, not more than one shard. Okay, so now we can see that there is minimum number of rebalancing happening, and so solving this problem, what we can do here is we can do some level of replication. Like earlier, if we were doing replication of shard 1 to 2 and 2 to 3, and for data for shard 3 will be replicated to 1. So when user ID came at 3, it got saved at 2. Okay. Now if I want coming at 3 again, so it will search in 4 and it won't get. So it can ask the next shard. So do you have this data? So we can, if that primary shard doesn't have data, we can ask to n number of shards, and n here is the number of replication we are doing. So since we are doing only one extra shard replication, So we can ask to one shard, hey, two, you have this data or not? And we can do this also clockwise. So yeah, shard 2 will tell, yes, I have this data, and so shard 2 will return to 4 and it will return. So like this, we can do some replication so that if rebalancing happens, then data is not lost. We won't say that we don't have data if data is there. Okay, so we have solved this problem, but again, the first problem where every data was going to one particular shard only, that problem here can also happen. First of all, we'll see that what are the changes happened to shard 4. So when shard 4 comes, you can see that this three mod value 3 and 4 is only getting changed. Rest all is same. So this is the new after coming 4. This is the old one, this table. So we can see that there is only difference between these two. Uh, Rest all are same. Now comes to another problem. Let if we somehow got the shard got placed in three consecutive mod values. So what will happen is all the data coming to 5, 6, 7, 8, 9, 10, 0, 1, 2 will go to shard 1. Only data coming to 3 will come here and 4 will come at 3. So again, equal replication is not happening, which we wanted at first place. We want our shard to have equal data, which is not happening here. So whenever this happens, what we'll do is we will create some virtual nodes of these shard and place in at another random values. Okay, at random we'll place like, so this is the virtual node of shard 1. It is placed in 7. So if anything comes to 7, it will be saved as shard 1, not 3. So if we can do these kind of replications, place these virtual nodes all over the ring at random points like this, we will make sure that we are dividing data equally. Okay, so again, at 11, if anything's come, it will go to 3. Earlier it was going to 1, because since now we have a logical virtual node here, so it will go to 3. So like this, we are solving this problem also. Okay. So consistent hashing, we have with consistent hashing, we have solved both our problems, and we have also seen that some data replication can also happen here. And if we do data replication at particular level, not to all nodes, we can still manage to get the data, and it will also help us in maintaining availability, since their data is getting replicated to our shards are highly available. Our every master shard will have knowledge of the which shard is next to me. Okay, so it has knowledge. Like this is shard master for 4, anything coming to 3 or 4. So it has knowledge which is next to me, which are the secondaries and where we are replicating the data. Okay, so like this, we have solved both our problems. I hope you like this video. Do let me know if you want me to create video on any other HLD topic. I will happily create video on that. Till then, take care.